Greetings and welcome to Astrophotography Japan. If you watched a few of my previous YouTube videos, well then welcome back. My name is Paul Cheesegel and I am an amateur astrophotographer. I'm really excited because in this video I will attempt something that I have never done before and share with you that experience. I also have a bunch of new equipment to try out. This video is about my first attempt at planetary imaging. At this recording, I already completed the imaging at a site a few kilometers away from my home in Yokohama at a local public park. Actually, I was very fortunate to get such a nice night for planetary imaging in the heat of the hot Tokyo summertime. There's not many nights when one can do any imaging. So, in the 18 months or so that I have been doing astrophotography, I have not seriously done any imaging of planets. That is because I generally have owned short focal length wide field telescopes. But earlier this year, I purchased this Svibony SV503 80ED telescope that has a focal length of 560 millimeters. Still not considered large, but a step up. Here is a scope equipped with a mounting plate specifically designed for attaching additional accessories such as the ASI Air or a guide scope. This mounting platform is 3D printed and custom designed specifically for the Svibony 80ED scope. I bought it from a company called 3D Astro. It's very strong, lightweight plastic plate, sold at a very reasonable price. I paid $18 for it and they even shipped it to Japan. I highly recommend it for any of the SV503 models. They have a version for each one. Now, an 80ED refractor is, of course, not an ideal telescope for imaging planets, but it's the biggest and the best I got. When combined with a good quality Barlow lens, I think it's possible to get a respectable magnification that may be more suitable for planetary imaging. I have two Barlow lenses. One is a 2x focal extender, and the other is a 3x focal extender. Actually, I'm not sure if there's a difference between a focal extender and a Barlow lens, but I think maybe not. They are both 1.25-inch Explore Scientific optical lenses that are very good quality. Each have multiple lens elements, some of which I believe are made of EB glass. These lenses have substantial mass. They are about 250 grams each. Frankly, I have used a Barlow lens in visual imaging by inserting it in my diagonal just upstream of the eyepiece. This worked very well. These Barlows give a great visual image, but I was not sure how to use them in an astrophotography imaging setup. Where do you put it? Will you need any extension tubes to reach focus? Does a Barlow require a certain back focus distance? I had lots of questions, so it made a lot of sense to explore the equipment setup during an afternoon and do a little bit of daytime imaging. So here's the setup that I worked out using the Svibony 80ED scope, a Barlow lens, and my ASI 523 MC Pro color camera. My daytime target was a high-tension electrical tower that you can see in the distance down my street. And based on Google Earth, the tower is exactly 415 meters away from my tripod. That is 1,351 feet. Not only was this a good idea for working out the optical train arrangement, but it was fascinating to see the magnification power and resolution of this telescope on a daytime target. You cannot quite comprehend this while looking at stars at night in the sky because you have no personal reference frame for how big or small something is while looking through that telescope. But when you look at a known object, the situation is different. I recommend you try this. You can see how small the tower looks in the distance in this photograph. At first I worked out the optical setup at the full focal length of the telescope, 560 millimeters. In this arrangement, the focal tube connects to the extensions via a 2-inch T-ring that is inserted into the end of the focus tube. Just upstream of that, in the middle, I included spacers and a ZWO filter drawer to avoid extending the focus tube out too far, which could potentially introduce some instability. In this arrangement, I was able to limit the focus tube extension to 49.5 millimeters, even though it was designed to extend out to a maximum of 90 millimeters. Frankly, the focus tubes on the SV Bony 503 telescopes are all very sturdy, high-quality rack and pinion design. I did this just as a precaution. So in this setup you can see I am using the ZWO ASI 533MC Pro camera. As you know, this is a very popular, economically priced, astro-dedicated, cooled imaging camera for deep sky astrophotography. Of course you can use it for planetary photography as well, but there are perhaps better options for planetary imaging. I have recently acquired one such theoretically better camera for planetary imaging, the newly launched ASI 678 MC camera. Part of the intention of this video is to image Jupiter or Saturn with each of these cameras and compare the results with other things being exactly equal to determine, are planetary cameras actually really better for planetary imaging? So using this setup, I could achieve focus with the 533 MC Pro camera and take the following image. Now, I don't know about you, but I think this is quite impressive at nearly half a kilometer away. On the left is the FIT image, single frame, taken with the camera, which you can see has a square sensor and a 3008 by 3008 image resolution. On the right is an iPad screenshot of the ASI Air Pro control software in video mode at a resolution of 1920 by 1080 pixels. Why video? Well, as you may know, one generally uses video to capture planetary images from which the best frames are selected and used for stacking. This process is kind of referred to as lucky imaging. Now, for even greater magnification, I mentioned that I wanted to use a Barlow lens. Shown here is the focal tube extension setup that I assembled to reach focus using the 2x Barlow lens. Quite frankly, I was using various available parts to simply extend the light path a bit further, and what those parts are is really not important. The important point is that the Barlow lens is at the very end, closest to the camera. I used a 1.25-inch T adapter to attach the camera to the Barlow lens. Placing it anywhere else in the imaging train did not allow me to achieve focus. It needed to be positioned immediately upstream of the camera. Sorry, I am not an optical expert and can only tell you what worked for me, not exactly why. Okay, so notice here, from the white edge of the OTA to the sensor, I measured 229 millimeters. What does this magnification with the 2x Barlow look like on an electrical power line from 415 meters away? Well, that is shown here. And finally, using a 3x Barlow lens, the setup is very similar to the prior example. As I suppose one might expect, the total distance from the white edge of the OTA to the sensor was actually the same at about 228 or 29 millimeters. And this is the image taken with the 3x Barlow lens from 415 meters away. Now you have to admit that is mighty impressive, especially the video image. Okay. So I had worked out how to set up my telescope with extension tubes and Barlow lenses. That night I assembled them according to the photograph, and it was very close to focus, which I then adjusted with a batten-off mask. Oh, by the way, I bought several 3D printed batten-off masks at 3D Astro as well. They're lightweight and strong. I recently set the sizes for my 3 scopes using the screws and then superglued the screws into place to make the OTA sizing and fit permanent. On that day of imaging, for me the big news was that I was not using the Skywatcher AZ GTI mount that you saw in all my previous YouTube videos. I recently got something new. Introducing the new ZWO AM5 harmonic strain wave gear mount. This was the first time I used it for an astrophotography project. My proposed imaging system at about 6 kilograms is featherweight for this mount, which has a capacity of 20 kilograms and no requirement for accurate balancing of weight distribution. So where did I do this imaging? Well, At 35 degrees latitude here in Yokohama, it turns out that Saturn only reached about 36 degrees at the meridian and Jupiter about 53 degrees at the meridian at this time in the summer of 2022. So I could not do this imaging in my backyard since the targets were too low and blocked by adjacent houses. See one of my other videos and you'll know what I mean. I needed to find an alternative imaging site. One of my favorite local go-to sites is Kawawafuji Park. It is a small park located a few kilometers from my house, and it's very interesting. As usual, my transportation to the park was expected to be by bicycle, with my equipment trolley, of course. And here is the route I take to the park, starting at a nearby busy street overpass. As you can see, the route to Kawawafuji Park winds through the neighborhoods, mostly along paved pedestrian ways with busy street overpasses, going by subway stations, grocery shopping stores, along greenery-lined walkways and small parks, with everything well-maintained, clean, and tidy. I'm sure now you can see why I moved to this area years ago with a young family for its outdoor beauty, safety, and friendly atmosphere. Okay, well, if everything goes as planned and the clouds kind of clear out as has been forecast, then this is where I'll be doing my imaging tonight. This place is called Kawawafuji Park. As you can see, what they did was they built kind of like a little miniature Mount Fuji here. And at the top of it is a observation lookout area. Now this hill rises about 20 meters above the ground level here. So it's above all the trees. And from up there, as I will show you in a few moments, you have a 360-degree view all around this area. Also out in that direction to the southwest is Mount Fuji. And this is kind of a lookout area to get some views of Mount Fuji when the weather is nice and the skies are clear, like mostly in the winter time. For astrophotography, Kawawafuji is an excellent location, but not perfect. First and foremost is the need to transport 20 to 30 kilograms of equipment up inclines and at least 54 steps to the top. That's physically challenging, even for a reasonably fit senior like myself. But high above the trees and grass below, you are usually even beyond the reach of the mosquito population in the hot, humid summertime. The second issue is exposure to wind. It is elevated by about 20 meters above the park and hence always windier than the ground below. From up on the top, you can see the downtown area of Yokohama City by Tokyo Bay in the distance. The tallest building there is Landmark Tower, the second tallest building in Japan. And this morning, because the air was fresh and clean and without the usual summertime haze, we actually have a clear view of the top of Mount Fuji, rising above the Japan mountains off in the distance. Pushed skyward by the intersection of three tectonic plates at that point, Mount Fuji is an active volcano that from the top offers a rare view all the way down to the ocean level. In my younger days, I climbed it 5 times. You can only do that in July and August when the snows have melted and the hiking paths are considered safe. The forecast on the night of viewing was accurately predicted by Clear Outside, one of the web applications that I like to use. The moon was setting about a little after midnight and the skies looked clear. Okay, looks like we're all ready to go here. We got the bicycle loaded up. There's my backpack. And there's the little trolley in the back. I guess it's 9:30 or 10 o'clock at night. 49, 50, 51, 52, 53. Last step. 54. You can probably just imagine 54 steps with that load in 30-degree weather, the way I feel right now. But I'm at the top and I'm ready to do astrophotography. Okay, there's the city of Yokohama in the background over there, and you can see I set up on the fence there a large tarp. That's my wind block, and I'll set up my tripod right over there next to the wind block. Okay, as we say in Japanese, chodo ii desu. It's perfect. Solid, stable, pointing north. All right. All right, now let's take out the telescope. I bought an empty photography case on AliExpress. Put in some nice padding. It's a perfect fit for my SV Bony SV503 80ED telescope. Okay, I wanted to make a few comments about this use of the Barlow lens. You can see here I set it up the way I showed you in the earlier picture. I've got my 2-inch nose adapter here, my ZWO filter drawer, followed by some kind of extender piece, the Barlow and the ASI 503 MC Pro. So I'm imaging Jupiter with this one, or
or have just finished imaging Jupiter with this one. And a couple observations. One, with this 3x Barlow lens, it's interesting that when you center onto the planet, that it drifts a little bit because it's at such a high magnification until the tracking or the guiding actually kicks in and then keeps it in the center of the field. So sometimes I have to sort of like position the planet out to the top right-hand corner. I let it drift in, and hopefully it starts to guide as it gets toward the center of the screen. So that was a little bit surprising to me. But the amazing thing is the hand controller for this AM5, when it's in the kind of the slow motion mode, just a little touch with the thumb and it moves it on the screen just a tiny little bit. So it's a very sensitive and accurate hand controller. I like it. So things are going good, and I'm getting some surprisingly good images, and you can probably see from the videos that we're dealing with some really nice skies tonight. I think there are either 4 out of 5 or 5 out of 5 on the seeing conditions. So if I can't do it tonight, then I probably don't have a chance, because this is a perfect seeing conditions tonight.
Speaking of seeing conditions, let me show you some examples. Here are a few video snippets taken during the live imaging sessions. The first image is of Jupiter taken using the 3x Barlow, which gives a 1680 millimeter focal length. The video setting here is 720p. On a good night like this, there appears to be very little atmospheric distortion and wobble of the image. If you looked up at the stars with your eyes, they also looked quite stable in brightness, with very little of the usual twinkle. In the next image of Jupiter, I bumped up the apparent magnification by selecting the Video 360p option. Notice at this magnification, chromatic aberration is readily apparent. Keep in mind that the Zvebony 80ED refractor that I am using is a doublet design with FPL 51 glass. It is not a fully corrected triplet apochromatic scope. Under normal use astrophotography conditions, I cannot see any chromatic aberration. But at this super high magnification, this can be expected. This last sequence is Saturn. It was videotaped at a 480p resolution. All night I was taking images at about 50 milliseconds per frame exposure time. It seemed like a reasonable number, and I was generally collecting data for about 60 seconds or sometimes up to 80 seconds per session. So these settings result in 1,200 to 1,600 separate frames taken of a planet during each video session. If you try to take photographic snapshots of the planets instead of videos, you can see this would be an overwhelming number of images to process. But just for fun, I took a few photo snapshots shown here.
Well, as you can see, the sun came up. I ended up staying out all night. After midnight, the sky cleared up quite a bit and then pretty much was clear all night long. So I had a really good time working with this ZWO AM5 mount and my Zvebony 80ED telescope, and I'm looking forward to a lot more adventures in the future. And I'm all packed up and ready for the descent down the mountain. A little easier than coming up, but still rather challenging. Yo! That's 53 more to go. 2, 3, 4. Okay, I made it down the steps, hooked it up to my bicycle. AM5's leading the way. Time to go home.
So let's talk processing. Now, there are a number of different video editing software available for planetary image processing, and perhaps the most popular is using a combination of AutoStackert and Registack 6 software. AutoStacker seems to be popular for taking your AVI video images, selecting the best frames, and exporting a single stacked image, such as a 16-bit color TIFF file. The software gives you flexibility to select the stringency of the frame selection process and many other features, offering flexibility to customize your exported photo. I watched a 5-minute YouTube instruction video published by Jim at Carolina Sky Astronomy, and afterwards I was easily able to use it on the first try. Registax is also a stacking software, but frankly I could not get it to work with my AVI files. Perhaps my AVI format is incompatible somehow, or I was doing something wrong, so frankly I gave up. However, I could import the AutoStacker stacked image into Registax and use the wavelet editing software there to fine-tune the image. This feature helps to bring out fine image details and refine the photo. By using this combination of AutoStacker and Registax, a lot of astrophotographers process their planetary photos. I did that. I tried. But frankly, I could not get the images to be any better than the images provided by using the automatic stacking feature of the ASI Air Pro computer. The feature is built into the menu system of the image storage database within ASI Air. When you navigate to the image database, you can find your video images under the video file, of course. Then, when you select an AVI image to view, you are provided the option to stack it right there. All you need to do is press the icon on the bottom lower corner of the screen. This image that I selected took about 4 minutes to stack. You can then adjust the sharpness of the image by using the slider on the right-hand side of the screen. Once adjusted, you can then save that image. I also take an iPad snapshot as well, where the image can be then edited on the iPad on the spot. The disadvantage of this studio feature of ASI Air Pro is there is no custom options available for adjusting the stacking process. How it works and what are the settings are all unknown, but surprisingly, it does a very good job of stacking and initial edits to the photo. It is exported as a FITS file that can then be edited further. So, prior to this astroplanetary imaging session, I never used AutoStacker and Registax before, and perhaps my skill set with them was inferior to the automated processing done by the ASI Air Pro. Whatever the reason, my best processed images came directly from the ASI Air, and those will be the images I share with you today, and now you know why. One thing we did not discuss yet was the quality of the images comparing the ASI 523 MC Pro Deep Sky Cooled Color Imaging Camera with my newly purchased ASI 678 MC Planetary Imaging Camera. I took a number of images of both Jupiter and Saturn with each of these cameras in hope of comparing the results. I was wondering, are planetary cameras really better for doing planetary imaging? Looking at the specs, one could make that argument. As shown by the red arrows, the pixel size is smaller, suggesting higher resolution, and frame rates can be faster, although in this comparison there is not any notable difference between the specs. But APS-C sensors and full-frame sensors are slower for video imaging, and these planetary cameras are definitely faster. Still, I surmise that the high resolution on small planetary targets should yield better results. Well, I have to say that the results were totally inconclusive. I was consistent with the same frame rates, but I have come to realize that there are so many factors affecting the image capture and processing, it is not possible to make this kind of comparison with my amateur equipment. Maybe a 10-inch Schmidt-Cassegrain with very high focal length and resolution could pick out differences between these cameras for planetary imaging applications, but not my 80 ED doublet refractor. So, I think these are my best images from the night. It was an exciting night and I struggled, but I learned a lot too. I learned it is best to polar align at a reasonable focal length, certainly not while using a Barlow lens. Polar aligning with the guide scope is one possible option with ASI Air Pro if necessary. I learned that planetary cameras with small imaging sensors under high focal length can make it very difficult to locate a planet into the field of view. The go-to system I was employing in ASI Air Pro did not seem to function consistently at such high apparent focal lengths. Now, this could be due to the lack of visible stars in a Bortle Class 7 and 8 environment like Yokohama. I'm not sure. That is speculation, but there were times when the go-to system could not position the planet into my field of view. It would endlessly analyze the go-to image data and not find a target. And other times it was in the field of view while in the preview photo mode, but not in my field of view in the video mode, even at 1080p resolution, which is the widest. It was frustrating. If not for the fantastic joystick hand controller of the ZWO AM5 mount, I may have even given up at times. And finally, I can personally verify that perhaps the most important factors in planetary imaging are aperture, focal length, and seeing conditions, not camera pixel size. At least I had the third factor, seeing conditions, being very favorable for me that night. Indeed, for me, this astrophotography session was another intellectual and local travel adventure. I think that planetary imaging is intrinsically more difficult than deep sky nebula, galaxy, or star photography. But I would encourage you to try it too, even if all you have is a small refractor like me, because it is not about competition and being the best, but about doing the best with the equipment that you have and enjoying the challenge. For me, I'm satisfied with these photos, but I still think I can improve on them. And someday I will try again when the skies are right and the planets call my name. Thank you for joining me on another Astrophotography Japan adventure. My name is Paul Cheesegel, and I am an astrophotographer.